Chapter 4, Metals and Non-Metals. Introduction. We have learnt in previous classes about matter and the changes that it undergoes. We learnt about physical and chemical changes in matter. In a chemical change, a substance undergoes change to form one or more new substances. Such change is called a chemical reaction. A substance that cannot be broken down further into simpler substances by chemical reactions is called an element. Carbon, oxygen, iron, copper, gold and silver are examples of elements. There are about 118 elements known till now, of which more than 92 are naturally occurring elements. The rest are human-made elements. Two or more of these elements combined together in fixed proportion to form compounds. Can you imagine the number of compounds that can be formed from 118 elements? All the matter that exists around us is made up of elements and compounds and their mixtures. Elements are further made up of small particles called atoms. Hence, we can say that the basic unit of matter is atom. An element has only one type of atom which are different from atoms of other elements. For example, an atom of oxygen is different from an atom of copper in its mass and properties. Thus, an element is defined as a substance made up of only one type of atoms. When an element undergoes physical change, its atoms remain unaffected. For example, atoms of iron are same in the solid, liquid or vapor state. However, when an element undergoes a chemical reaction, there are changes in its atoms. An atom of sodium metal is different from the atom of sodium present in sodium chloride. Let us learn more about the elements. What are metals and non-metals? Elements have different properties. Their properties depend upon the type of atoms they have. Based on the properties, elements are classified as metals and non-metals. You already know about metals and non-metals. Can you look at an object and decide whether it is a metal or a non-metal? Now discuss your lists with each other and rest of the class. What made you think whether an object is made of a metal or a non-metal? Take an example of a ball-point pen. The tip of the pen is shiny and strong, whereas the body is dull and not hard. The tip is made up of metal, but the body is made up of non-metal. Of the 118 known elements, only 21 are non-metals. There are some elements which have properties of both metals and non-metals. These are called metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium and polonium are the metalloids among all the elements. Some metalloids like silicon and germanium have special properties which make them useful for making electrical circuits and devices such as computers and calculators. Chemical properties of metals and non-metals. Metals and non-metals react to form different compounds. Metals do not react with each other. They react with non-metals to form different compounds. Non-metals react with metals as well as each other. Some metals and non-metals are very reactive and react at room temperature with many substances. Others are less reactive and react only at high temperatures. Metals like silver, gold, and platinum are called noble metals because they are unreactive. They do not react with other substances under ordinary conditions. We will learn about some of the chemical properties of metals and non-metals. Reaction with oxygen. Metals. Metals react with oxygen to form metal oxides. Metal plus oxygen, metal oxide. Sodium and potassium are extremely reactive metals. They react vigorously with oxygen on exposure to air and catch fire. For this reason, they are stored in kerosene. 4Na plus O2 gives 2Na2O sodium oxide. 4K plus O2 gives 2K2O, potassium oxide. Magnesium and calcium are reactive. They react slowly on exposure to air and get covered by a layer of oxide which prevents further reaction. However, on heating, they burn with a brilliant white flame to form oxides. 2Mg plus O2 gives 2MgO, magnesium oxide. 2Ca plus O2, 2CaO, calcium oxide. Copper and mercury are very less reactive. They react with oxygen only on strong heating in air and do not burn. 2Cu plus O2 gives 2CuO, copper oxide. Metal oxides are generally basic. Non-metals react with oxygen gas to form non-metal oxides. Non-metal plus oxygen gives non-metal oxide. Carbon burns in oxygen to form carbon dioxide. C plus O2 gives CO2. Sulfur burns in oxygen to form sulfur dioxide. S plus O2 gives SO2. White phosphorus is very reactive and catches fire as soon as it comes into contact with oxygen. However, it does not react with water. For this reason, it is stored in water. Non-metal oxides are acidic. They turn blue litmus red. The carbonated drinks contain carbon dioxide gas dissolved under pressure. It reacts with water to form carbonic acid, H2CO3. Carbonic acid gives a tangy flavor to these drinks. When a bottle of aerated drink is opened, the carbon dioxide gas is released in the form of a fizz. After some time, when all the gas is lost, the drink loses its flavor and tastes like sweetened water. Reaction with water. Metals react with water to form metal oxides or metal hydroxides along with hydrogen gas. Metal plus water gives metal hydroxide plus hydrogen. Metal plus water gives metal oxide plus hydrogen. Sodium and potassium react explosively with water to form their hydroxides. 2Na plus 2H2O gives 2NaOH plus H2. 2K plus 2H2O gives 2KOH plus H2. Magnesium reacts with hot water to form magnesium oxide. Mg plus H2O hot gives MgO plus H2. Zinc and iron react only with steam. Zn plus H2O steam gives ZnO plus H2. Less reactive metals like copper, gold and silver do not react with water even at high temperature. Non-metals do not react with water. Reaction with acids. Most metals and non-metals react with dilute or concentrated acids. Here we will study the reactions with dilute acids only. Metals react with dilute mineral acids such as hydrochloric acid and sulfuric acid to form different compounds and hydrogen gas.
These compounds are called salts.
Metal plus dilute acid gives salt plus hydrogen gas. The speed at which the reaction occurs depends on the reactivity of the metal. Highly reactive metals react very fast, whereas moderately reactive metals react slower. These metals displace hydrogen from the acid to form salts. There is also evolution of heat in these reactions, which leads to a rise in temperature. There are some metals which do not react with dilute acids due to their unreactive nature. These are copper, mercury, silver, gold, and platinum. Sodium, potassium, and calcium react very fast. 2Na plus 2HCl gives 2NaCl. Sodium chloride plus H2. 2K plus H2SO4 gives K2SO4. Potassium sulfate plus H2. Ca plus H2SO4 gives CaSO4. Calcium sulfate plus H2. Zinc, aluminium, and iron react slow. 2Al plus 6HCl gives 2AlCl3 aluminium chloride plus 3H2. Zn plus H2SO4 gives ZnSO4 zinc sulfate plus H2. The hydrogen gas evolved can be tested by bringing a burning matchstick or splinter near the mouth of the test tube. It burns with a pop sound. Many food items that we eat are acidic. Vinegar, tomatoes, pickles, citrus fruits, etc. have acids in them. These foods are not stored in metal containers. The metal can react with the acid to produce toxic compounds, harmful for us. Non-metals. Non-metals do not react with dilute acids. They react with concentrated acids to form complex products, about which you will learn in the higher classes. Reaction with bases. Metals. Some metals like aluminium, zinc, and lead react with strong base like sodium hydroxide, NaOH, or potassium hydroxide, KOH, to liberate hydrogen gas and form complex compounds. Non-metals. Reactions of non-metals with bases are complex, which you will study in the higher classes. Displacement reactions of metals. In a displacement reaction, a more reactive metal displaces a less reactive metal from a solution of its salt. Zn, blue, plus CuSO4, colorless blue, gives ZnSO4, reddish-brown colorless, plus Cu, reddish-brown. In this reaction, zinc is more reactive than copper, so it displaces copper from copper sulfate solution. Similarly, Mg plus ZnSO4 gives MgSO4 plus Zn. Here, magnesium is more reactive than zinc. Based on the above two reactions, you can see that magnesium is most reactive and copper is least reactive among these three metals. By carrying out similar reactions using different metals and their salt solutions, metals can be arranged in decreasing order of reactivity. Such a series in which metals are arranged in decreasing order of reactivity is called the reactivity series. In the reactivity series, metals are arranged from top to bottom in decreasing order of reactivity. The metal on top is the most reactive metal, and the one at the bottom is the least reactive metal. Hence, a metal can displace another metal which is lower in the series from its salt solution. For example, calcium can displace lead from lead chloride solution, but lead cannot displace calcium from calcium chloride solution. Comparison of properties of metals and non-metals. Metals exists mainly as solids at room temperature. Non-metals exist in all three states of matter. They show luster. They do not have luster except iodine. They are malleable and ductile. They are brittle. They are good conductors of heat and electricity. They are bad conductors of heat and electricity, except graphite. They are sonorous. They are non-sonorous. Their oxides are basic. Their oxides are acidic. They react with water to form hydroxides and hydrogen gas. They do not react with water. Most metals react with dilute acids to form salts and hydrogen gas. Non-metals do not react with dilute acids. Corrosion of metals. You must have seen rust on iron objects many times. What exactly is it? The outer surface of the iron object gets covered with a brown-colored layer of rust which keeps falling off. The rust continues to form till the iron is used up. Similarly, copper objects turn green and silver objects turn black with time. This is called corrosion of metals. Corrosion is defined as the slow eating away of metal on exposure to air and moisture. Let us examine corrosion in common metals. Corrosion in iron, rusting. When iron is exposed to air and moisture, it combines with water and oxygen to form rust, which is an oxide compound of iron. Both oxygen and water are necessary for rusting. Rust is a hydrated oxide of iron, Fe2O3. Since it is a metal oxide, it should be basic in nature. We can check the nature of rust by the following activity.
Corrosion in copper.
Objects containing copper also corrode on exposure to air and moisture. These objects get coated with a green layer of basic copper carbonate, which is a mixture of two compounds, copper carbonate and copper hydroxide. Corrosion in silver. Silver objects turn black on exposure to air. This happens because the silver metal reacts with the sulfur compounds present in air to form silver sulfide, which is black in color. Prevention of corrosion. Corrosion can be prevented if direct contact of metal with air and moisture can be blocked. This can be done by different methods. Some of these are as follows. Oiling and greasing. Iron parts of machines are coated with oil and grease to prevent their contact with air. Galvanizing. Iron objects are coated with a layer of zinc, which is more resistant to corrosion than iron. Electroplating. Iron objects are coated with a layer of another metal such as tin and zinc by an electrochemical cell. Alloying. An alloy is a mixture of two or more metals in definite proportions. Alloys are made to improve the property of a metal. For example, iron easily rusts, and to prevent rusting, it is changed into stainless steel by mixing with nickel and chromium metals. Stainless steel does not rust and is suitable for making utensils and machine parts. Similarly, aluminium is very light but not very strong. It is mixed with magnesium to make magnesium, which is strong and is used to make the bodies of aircrafts. Uses of metals and non-metals. All things that we use in our life are made up of metals and non-metals and their compounds. Some uses of metals and non-metals are listed here. Metals. Iron is used as steel in construction of buildings and in making machines. It is also used in making railway tracks, coaches, and other automobiles. Aluminium is used in making aircrafts and window frames. Iron, cobalt, and nickel are used to make stainless steel, which is used to make utensils and machine parts. Gold, silver, and platinum are used in making jewelry. Copper and aluminium are used to make electric wires. Aluminium foil is used for packaging. Tin is used to make containers and in electroplating. Metals like iron, zinc, and manganese are present in our body and help in metabolism. Non-metals. Oxygen is used for breathing by most of the living organisms. Water is made up of two non-metals, oxygen and hydrogen. Nitrogen is used to make fertilizers. Phosphorus is used to make matches, crackers, and fertilizers. Sulfur is used to make sulfuric acid, a very important industrial chemical. All fuels are mainly made of carbon along with hydrogen, nitrogen, and sulfur. Diamond is used in making jewelry. Chlorine is used to disinfect drinking water. Bodies of all living organisms mainly contain non-metals like carbon, hydrogen, oxygen, along with nitrogen, sulfur, phosphorus, etc.